Hi guys, welcome to this page of the notes, and what we're going to do here on this page is talk about how you find the inverse of a matrix. Previously, I gave you two matrices and asked you if they were inverses, and all you had to do was multiply them together. But what if I just give you a matrix and ask you to find its inverse? Well, it turns out we have a nice little formula that'll help us do that. So if you're given this matrix, matrix A, and you're asked to find the inverse, right? Well, this matrix has 4 elements. It's a 2 by 2 matrix, and this is the only kind of matrix I'll ask you to find the inverse of. We'll only do 2 by 2 matrices. You won't have to find the inverse of larger matrices. So just 2 by 2. So I have this matrix A, B, C, and D, right? We've seen this before. Here's how you find the inverse matrix, right? This A to the negative 1 means inverse matrix. Here's the way it works. What you're going to do is you're going to find the determinant of matrix A, right? So A, B, C, D. Well, there it is. A, B, C, D. The bars mean find the determinant, and you're going to divide by that determinant. So it's 1 over the determinant. And then the last thing you're going to do is multiply this guy by a matrix, but we have to do a small transformation, right? And here's the way the transformation works. What you're going to do is you're going to take A and D, whatever these elements are, and they're going to switch places, right? So now I have D up here and A down here, right? We just switch places, okay? And then you're going to take whatever element B and C are, and you're going to make them negative, right? So negative B and negative C, right? Now, here's the deal. If B and C were positive numbers, well, when you make them negative, now they're going to be negative. But if B or C was already a negative number, when you add that negative sign, you would then actually make the element positive. So be careful with your signs there. And here's what you wind up with. Remember, the determinant is just a number, right? So what you're going to have is 1 over a number, right? This is going to be a constant. And what we wind up with is scalar multiplication, right? You're going to take this transformed matrix where you switch A and D, right? They switch places. You make B and C negative, and you multiply that transformed matrix by a scalar product, right? Multiply that scalar through, and you get your inverse matrix. So let's go ahead and try one together. I think it'll make a lot of sense here as we do it. I'll leave this here so you can still see the equation as I run through and do it. Here's what we're going to do. I want to find A inverse. Well, here's what I need. I know that A inverse is going to be equal to 1 over the determinant of matrix A. So let's find that. 3 times 2 is 6. 4 times 1 is 4. So I would have 6 minus 4, right? Because it's bottom minus top. That's all going to be multiplied by my transformed matrix. Remember, A and D switch places. So now it's going to be 2 and 3. And B and C, I have to make them negative. So minus 4, minus 1. That's it. That's what this formula tells you to do, right? 1 over the determinant, and then transform the matrix. So here we go. 6 minus 4 is going to be 2, so I wind up with 1/2. Multiplied by my transformed matrix, 2, negative 4, negative 1, and 3. Let's go ahead and do that math. 1/2 times 2, the 2's cancel, I'm left with a 1. 1/2 times a negative 4, the 4 is divided by the 2, which leaves you with a 2, but I also have the minus sign there, so that's going to be a minus 2. 1/2 times a negative 1 would be a negative 1/2. And 1/2 times a 3 would be a positive 3/2. And what you have just found is your inverse matrix. Inverse matrix. Guys, head on over to the next page and let's try a couple more of these. In fact, I would even encourage you to, if you feel comfortable now with this, go ahead and try these ones on your own, see how they go. Check back and see if you get what we get. Here's what I want you to do. Matrix A and B are, actually I ask you, are matrix A and B inverses of each other? Well, you've got two options, right? Two ways you can do this. You could either multiply these guys together. If you get the identity matrix, then yes, they're inverses. Option number 2 is you could go ahead and choose one of these guys, right? Find its inverse. If that matches the other matrix, then yes, they're inverse. I'm going to do both of them for you because I want you to see them both. So this is going to be method number 1. Where I will multiply these matrices together. A times B. All right, let's go ahead and do that. Here's what I get if I multiply A times B. Remember, row times column. So 0 times 0 is 0. 1 times 1 is 1. 0 plus 1 is 1. Off to a good start. 0 times 0 is 0. 1 times 2 is 2. 0 plus 2 is 2. Ooh, yikes. I would have needed that to be a 0. Since it's not a 0, I know I'm not going to get the identity matrix, and I can say already, no, these are not inverses. But let's keep going for completeness sake, right? We might as well finish it. 2 times 0 is 0. 1 times 1 is 1. 0 plus 1, well, that's a 1. And finally, 2 times 0 is 0. 1 times 2 is 2. 0 plus 2 would be 2. So I do not get the identity matrix, which tells me no, these are not inverses. But here's method number 2. What I do is pick one of the matrices, find its inverse. If I get the other matrix, I know that they're inverses. I'm going to go ahead and pick B since it's got more zeros in it. We like zeros in matrices. It makes our math easier. So here we go. We're going to find the inverse of matrix B. And remember, here's the way it works. I'm going to do 1 over the determinant. Well, 0 times 2 is 0. 0 times 1 is 0, and what I wind up with is 0 minus 0. I actually can stop there. I'll explain this to you in just a second. Let me transform my matrix, switch those guys. They switch places. That's going to be negative. That's going to be negative. Again, there's no point in putting a minus sign in front of a 0 because 0 can't be positive or negative. Let's talk about this for a second. I have 1 divided by 0. Is that allowed? Yeah, you can't divide by 0. Remember, division by 0 is undefined, which means division by 0 is undefined, and what that means is that B, this matrix, actually doesn't have an inverse, which is totally possible. It is completely possible for matrices to not have inverses. Here's an example of one. B doesn't even have an inverse due to division by 0, which is undefined. And so there's no way that A and B could be inverses. B doesn't even have an inverse. So no, they are not inverses. B doesn't even have an inverse. Here we go. I got another one for you. Find the inverse of A if it exists. All right, here we go. I need to do finding the inverse of A. I got to divide by the determinant. So 1 over, well, here we go. 1 times 4 is 4. That's going to be 6. So I'd have 4 minus 6 should be a negative 2. I multiply by my transform matrix, which means those guys flip places. 4 and 1. And these guys are going to be negative, negative 2, and minus 3. And then we go ahead and do that scalar product. Negative 1/2, right? This is a negative 1/2 times 4. Well, it's going to be negative, and 4 divided by 2 is 2, so I get a minus 2. Okay, negative 1/2 times the negative 2. The negatives will cancel each other out. The 2's will cancel each other out, and I'm left with a 1. Keep going. Negative 1/2 times a negative 3. Well, the negatives will cancel each other out. 3 divided by 2 would be 3/2. And the last one, negative 1/2 times 1 is just a negative 1/2. So yes, A does have an inverse, and you guys just found it. There's my inverse matrix. Guys, great work on these ones. Head on over to the next page of notes, and we'll try a couple more example problems. I'll meet you there.